Hello everyone, and welcome back to CAD Builder Training. In the previous video, we saw how we set up a cutout tool bit. In this video, we'll follow suit for our pocket and drill bit operations. So we'll jump right back into the cut list, find our tool library, and let's say you're using some 3/8" down cut for your standard plywood pocketing ops. I will just use the 3/8" compression. I'll copy it and we'll go through what we need to update to make it work. So I'll copy this 3/8" compression. I'll name it 3/8" down cut. Maybe I'll update the image. So instead of the compression end mill, I will do the down cut end mill. Description section, I will update the SKU, make and model, whatever is applicable. Diameter, I'll keep the same at 3/8. Again, this needs to reflect whatever is read directly from the caliper. Pass depth, I will leave at 0.8. Extra cut depth is not relevant because I won't be using this for cutout operations. But if I wanted to, I can specify something here. Maximum cutting depth, again, it will be the useful cutting length of the bit. I will leave it at 1.5 inch. Step over, this is going to be, of course, very relevant for pocket operations. I will leave it at 1/10 of the diameter. Entry point, it's only relevant for cutout operations, so I'll just leave it as is. And then I go through its toolpath specific settings. I do not want to use it for cutout, so I uncheck that box. I do not want to use it for boring operations. It's generally inadvisable to use down cut end mills for boring ops. I will enable it for dado operations. And that's it. Once I set this in the tool set, CAD Builder will recognize that this can be used for pocket operations and use it accordingly. Now, if you need to cut out a smaller dado, let's say you need a 1/4" dado instead for your 1/4" back, which will slide into your sides. A 3/8" down cut will obviously not be able to do that because it's too big for the dado groove. So perhaps you might want to have some multiple dado sizes, and then CAD Builder will just pick the biggest one that can fit inside the opening and can get the job done the fastest. So let's say you are using some 1/4" down cut. I'm going to reflect this within my tools here by copying the 3/8" down cut and again making the appropriate adjustments. I'll name it 1/4" down cut. I'll update its diameter to be 1/4 inch. Pass depth, the narrower tool bits are going to be able to handle smaller maximum depth across each pass, so I'll use maybe 1/2 inch for the pass depth. Extra cut depth, not relevant, so I'll leave it at 0.06. Maximum cutting depth, I'll leave at 1.5. Step over, I'll add it to be 0.25 divided by 10. Entry point, not relevant because I'm not using it for the cutout. And still, I will just enable it for dado operations. Let us do this now for a drill bit. Let's say I'm using a 5mm drill bit for my 5mm shell pin holes. I can either create a new bit or I can use an existing one. So I'll just use this 5mm drill bit that's already in my tool set. I will leave the name the same. Again, I'll skip the edit shape. I'll leave the thumbnail the same, description. I might want to put it in my make and model. And then I get my general tool properties. 5mm is about yay much in inches, so I'll leave that there. Pass depth, I will leave it at 1/2 inch. Extra cut depth, I will do 0.006. Again, not relevant because I'm using it for the cutout, so it doesn't really matter what I put here. Maximum cutting depth is going to be relevant in determining what holes this drill bit can and cannot bore. If that maximum cutting depth is less than the required depth for the shell pin, then obviously it cannot be used to make the hole. So I'll leave this at, say, 0.8 inches. Step over and entry point are irrelevant because I'm not using it for the cutout and the dado operations. And then within the operation specific stuff, I uncheck it for cutout, I uncheck it for dado, I will check it on for drill, and there's only one special parameter to take care of, which is the depth compensation. This refers to the extra amount of depth that the drill bit must be sent to in order to fully cut out the hole that you need. If you look at, for instance, at a brad point drill bit, you'll notice that the tippity top portion doesn't have the full diameter that you would need to be removed whenever it makes that hole. If you can imagine the tool bit rotating, it would have like a W cross section at the bottom of the hole. This means that if you were to, for instance, need a 3/8" deep shell pin hole and you send that tool bit 3/8" deep, then the shell pin won't have the full 3/8 of 5mm hole that it can be inserted into. So to circumvent that, we have this parameter called depth compensation, which sends the bit ever so slightly deeper than the specified hole depth in order to ensure that the shell pin hole can fully fit into the hole. And this depth compensation should be measured from the tip of the brad point drill bit to wherever that full diameter starts along the tool. Usually something very, very small, but again, it will make a difference whenever you set some very specific settings. So once you have that down, then there's your drill bit, and then it's ready to be assigned onto your tool set. Join me then in the next video where we'll do exactly that, and we'll see how we can send it over to our G-codes. Thank you, and I'll see you then.